Doing the audio check. Can you hear me? I'm not able to hear anything.
That sounds like a Reza. If you want to join the queue, that's great. Your timing is perfect. Welcome back. This is our second TEAS session. We broke in the middle of the last discussion from the previous session, but first, before we can resume, we have to do our normal administrivia. We're required and asked to always show our note well. This is to ensure that all participants are aware of the process and procedures that govern how we operate. That covers both what is discussed here, and that it becomes part of our permanent record and it's recorded and made available. It also governs how we interact with each other. Next slide, please. And our leadership has, just go to the one after. Our leadership has asked to emphasize that we have a code of conduct. It's covered in BCP 54, and to keep it short, it's please be respectful and courteous of others, even when engaged in intense technical discussions, which are of course encouraged. The agenda, now onto our agenda. So we broke in the middle of, slot 4, which is okay because we actually had 40 minutes of open time right now. So we're going to give Adrian up to 40 minutes if you'd like to take it. And so we're going to start with that and continue. And then all the other slots are going to be just pushed further down in our 2 hours. And with that, back to Adrian, and we had Tarek and Reza in queue, and they're back in queue.
So thank you. While the slide comes up, it occurred to me during the break that I may be defending the current text a bit too forcefully. I'm the pen holder, and it's your text. So what we actually need to do is try to get some consensus on these points. That said, I propose that we just take Tarek and Reza on this slide and then make some movement through the rest of the slides in the hope of getting through them. So Tarek.
Great, Adrian, to thank you, getting clarity on these things. You're doing a great job highlighting what makes sense. My question now is about the connectivity matrix ID. And there is a need that to group multiple of these connectivity matrices, if you want to call them, or the way we call them, so that they match a specific filter criteria. For example, if I have still on point-to-point basic connectivity matrix, I have 2 of those, and I want to associate a class of service with them. Do I need to have an over grouping of these 2? And is that what is the thought, the thinking is?
I think it is likely. I'm hesitant here because you're moving from how we describe the slice to the customer, and then you're going from that to how you would actually start to realize and to deliver the slice in the network. Now, I understand that the second is important, and it seems to me very likely that there is a need to group together in delivery matrices or slices that have the same or very similar service characteristics.
Okay, thank you.
Reza.
Thanks again for the session. One comment and one question. I guess from the connectivity type traffic that we see here, it's good to consider that one as 2 group of unicast or multicast. because, for example, point-to-point in this case is unicast, whereas other one are potentially multicast. So this is one aspect that also maybe can clarify the type of the traffic we have. And there was some comment that we can group it into two categories, point-to-point and point-to-multipoint, and other are the kind of subset of that. We more or less, I think, in my opinion, this is correct, because at the end, when I go to my session about NBI, the modeling, we basically retouch some of this aspect that we have here. And another the comment is about the connectivity matrix. When we say matrix, so by definition, matrix means multiplicity, multiple row that, and in this case, matrix, if we are clear about that, means X and Y. When X is sender, Y is receiver. I just want to make sure that we are on the same category, because we talk about something and the definition of that is not 100% clear. VN talks about connectivity matrix, the way that X and Y they can send. And I think it might be a good idea to clarify that in the framework, that very clearly what we mean with the connectivity matrix. Thank you.
Yeah, I get you. I think that's important, and you're also right that getting alignment here with the NBI or the service Yang model is also fundamental. Yeah. Okay, I'm going to bow to the working group and continue then. So, Gian.
Yes, just a few comments from I think some of the other, I guess, discussions on mailing list about this topic. So I think what was mentioned just earlier, I think the grouping of unicast, flows and then multicast, but then as well, having that delineation in the grouping. But then also, in the description, I think it may have been commented on as well. Like when you look at the functional categories, and then you talk about C to C. So like, let's say the network slice controller, this is kind of the overall provisioning of the slices. But when you think about provisioning of the slices, the action is happening on the PE, not the CE. But then you have two pieces of it. You have the CE, which the provider side is seamless to the CE. He has its SLA and SLO, and then the PE is actually doing the provisioning. So when you look at it, just like the definition of each one, you're actually defining the PE role, but then the actual description has the endpoint communication, the CE to C communication matrix. So just a point that when you're reading it, it does look a little bit confusing, because you're actually talking about the PE role and actually provisioning by the controller, but then you're actually talking about the sending and receiving, like the endpoints, CE endpoints. Another comment also, and I think someone had mentioned, like since when you think of a single connection or connectivity, it's CE to C, point to point, and then like I guess when you think about a point to multipoint, like say multicast, and let's say like a source to leaf, sub LSP. Everything, I think the building block of any communication is a single unicast flow. So let's say hypothetically, if you took a single unicast flow, so like a point-to-point flow, and use that SLA and SLO, and then you can actually use that as a mirrored building block to build really any point-to-multipoint or multi-point to multipoint communication matrix. Thank you.
Yeah, okay, heard that. Greg.
Hello. I think that, well, at least my interpretation of what connectivity matrix is not related to data flows that are traversing it. So because, for example, if it's point to multipoint, it's not restricted to carry only multicast traffic. It can be a unicast. So that's... in my mental, picture, these are different.
Yes, and that's what took us into the definition of any to any, in as much as we were trying to represent that multicast flow in P2MP, not the potential of unicast flows. Okay, all I can say is this needs to go round the whole loop again, and we need to bash it out. And I'm not sure that now is the time, but I have heard that there are many different opinions about what we should be doing here, and we've got to drive that forward. Not to be outdone, what have we got? Gian, are you still in the queue?
Sorry, let me remove myself.
Okay, Jeff.
Sorry.
Can you hear me?
Yeah.
So I think it's important to really define where the boundary is, right? In point-to-multipoint, C will still be sending single copy, where P might be replicating if it's replicated traffic. Think about layer 2 service and flooding, right? Number two, it's not necessarily traffic, it's the connectivity model you described, commonly known as point to cloud, cloud to point, or cloud to cloud. And it defines SLOs, and even so you might be sending traffic to everybody, amount of traffic in total could be well defined, right? So if you add additional receiver, you might be actually running out of your quota as sending to cloud. So I think we are really confusing this too.
Yes. Interesting. Yeah. Okay. I'm going to fold all this in and try to come up with a thread on the list to drive this discussion further. So next slide, please.
We finally made it.
Yay. Yeah. So other changes that happened in 05. And this will come back still to whether we agree on the definition of connectivity matrix, but we had a debate about could you have more than one matrix per slice, and we wanted to allow the operator to choose one slice per matrix or multiple matrices per slice. And that's what we've settled on at the moment. It may change with the definition of matrix. We had then some debate about what is a service definition, and polished that. The main issue coming out of it was the connectivity per slice, which we just talked about, and what is an endpoint. And that was issue 5. And there was a figure at the interim which has found its way into the draft, to define the different possible positions of endpoints in CE, at the CE's port, at the PE's port, or in the PE. And to add to that, we added this thing called an ancillary CE to catch the idea of a service function which might be somewhere inside the provider's network. More on that later. We added a figure on the realization process, and that picked up some text from Med, Joel, and John Drake. The recent email exchange on that on the list, which is saying that these components are fine in the figure, but there need to be some clearer text describing what they are. So that's easy. Issue 7 on the workflow was agreed to make no further change, because the workflow is pretty much these things have to happen, but in any order. And then there were also a couple of editorials in it. Next slide. Oh, we're romping along. So this takes us into the further issues, and what's needed is an editorial pass. There's some really stale text in there that I think can be taken out, and there's a bit of duplication. There are a couple of emails, review comments kicking around. Louis, for example, sent comments, and that needs to be factored in. I have this open question on how we define endpoints. We've got endpoints, network slice endpoints, customer edge, and I think I want to get down to either service demarcation point or service access point. Service attachment point. Service attachment point is popping up at the moment in the ops area working group, where there's a Yang model that is intended to apply to L3SM and L2SM and other services as well. And it might be really neat if we could be consistent with that. So again, that'll be a posting to the list. And I think resolving that might actually help us with our network matrix discussion. What else have I got kicking around? Next slide is on converging with 8309, and then there's a slide for technology agnostic, and as I said, editorials from various people. And then I think some worked examples for simple services and mapping those to connectivity matrices may really help. So let's go to the next slide. And this is really about, do we say NBI and SBI? And it's a long-term issue across quite a lot of SDN-based stuff, is that my southbound interface may be your northbound interface, and calling it NBI or SBI can get confusing. So a proposal from Med here was to try to align with 8309 and reference the existing service models and then use the same terminology across all IETF network level sort of services. I think the NBI is pretty straightforward. We can talk about it as a IETF network slice service interface. The SBI is a little more debatable. We have to decide, is it a network model or is it a network configuration model, mapping to the 8309 terminology. And here is Louis with an opinion.
So hopefully you can hear better this time.
Yeah.
Okay. In the IETF concept, there's a IETF controller considered for the network. You're adding another IETF slice controller, even though you have a higher layer of slice orchestrator. I'm trying to understand that IETF network slice controller. What does it do that I can't get from a orchestrator or a controller in the bottom?
So the thing about orchestrators is you get them sort of at every layer. So the figure on the right here is maybe the one to look at. And in this picture, the orchestrator is up there in customer space. So the customer is working out what slices they want and then is issuing the slice service request. So as an operator, you don't have that slice orchestrator. You have the service request reaching your controller or I think it's called the network's slice controller in the main document.
I have an echo on the line, but the way I look at it is, I understand I have to build a network slice orchestrator that is not specific to a domain, and this is, we can discuss further, when you get to the IETF slice control, do I need really a controller or maybe a module within my current controller that can handle any slice requests? But that's something, I mean, I see some people coming online, so maybe they have opinions.
Yeah, and that is exactly the question, and that's kind of why the figure on the right, the figure 3, bundles those as all inside one controller, and then actually how it's partitioned in software is kind of an implementation deployment choice. Okay, Kariti.
Been a while. So the terminology that was used in the L3 VPN service model is not one that I'm thrilled with, because everything is a service model. But customer and network is definitely one way of doing it. You very rightly point out that, I mean, there are some drafts now which are the L3 VPN network models, which are not yet the device models, but they are a network-wide view of how this might get implemented. And then you need one more conversion as you have the network controller to say, this is what actually goes on a device. So, but, you know, I know it's maybe a little bit gimmicky, but calling them intent model and implementation model might be helpful, because you know, your northbound is my southbound. Your, I mean, you have all these orchestrators. So if you say customer, where does the customer really come in? The customer actually might come in even above all this. So the idea that you have a model that abstracts away from the implementation details. So if you say, here are the SLOs, I don't know how you do it, but make my network meet my SLOs or my SLEs, or make the network meet these SLOs. So in a way, you have a thing that says, this is what I would like, and then you have something that says, this is how it's going to be implemented. And I think that's maybe a little less sort of relative than northbound, southbound, or customer and network. I don't know. I agree with you that we need more uniform terminology across all the service models, but I'm just struggling with it, and that's just my current idea.
Yeah, and it's certainly true that we stumbled around for a while on the definition of customer, because there's a tendency to think of customer as the absolute sort of end user, or the person paying the bill.
Exactly.
Where what we've defined in this document is a customer is the person who makes is the entity, if you like, that makes the request for the service. But we can look at that again, and certainly if there's a robust definition of intent, better than what the super working group failed to do, then we should certainly look at whether we can glue that in.
Okay, thanks.
Kiran.
Just a clarification question that you have only downward arrows for the configuration. That is intentional, I guess. You do not collect any runtime or dynamic state for the configurations.
Well, you'll notice that figure 2 has got arrows in both directions, and they are the same arrows. So no, that's just inconsistent documentation.
Okay.
Lewis.
So actually, I was going to bring up the same comment about configuration. We should think of that as bidirectional, even though people tend to say configuration is unidirectional, but that's good. The other thing is, I think it would be useful in the alignment, if you really are going to head to tight alignment with 8309, is look at their use of orchestrator versus controller, because, for example, they call that middle box another orchestrator. And on one hand, it's really nice to be aligned with an RFC. On the other hand, if the terminology used it causes more confusion, it's okay not to follow it.
Yeah, point taken. I'll talk to the author of 8309 about that. Lue.
Yeah, just to confirm your thought on the endpoints, you're right. I mean, it could be the customer had the endpoints. We can have infrastructure endpoints. An example like a CUDU can have customer traffic, but their control plane traffic needs to be treated differently. So the endpoint could be anywhere, right? Could be in the customers, could be on the operator's network. It depends on what, if it needs any kind of specific or special treatment than what's normally offered. And by the way, and I know a lot of people mention QoS. I always think QoS is always there, regardless if you're slicing or not. So that protection is always there. I normally, when I look at it, I don't attach QoS to slicing. It helps within the slicing scope, but I don't know if it's, some people think QoS is slicing. Personally, just my personal opinion, I don't think it is, one for one.
Yeah, okay, those are both helpful points, and I think that the embedded endpoint ties in with Jeff's comment on point to cloud and things like that for the SLOs.
That's correct. Thanks.
Okay, next slide. I assume Lou is not still in the queue. He likes waving. So there was a question on the list asking about what it means to say technology agnostic. And so there are a couple of points here. We certainly know that how the service is provided belongs to the operator and not the customer. And we know that the same service, in other words, what the customer sees as a service, could be provided in multiple ways according to operator preferences or according to technology that's available. But the traffic supplied by the customer is a specific technology. That is, it could depend on the encoding on the attachment circuit, therefore there is some form of technology specific aspect of a network slice service. And the wrongly named attachment circuits are of a specific technology. So the AC is if the AC is part of the service, and it is in some of our models, then there is a technology specific aspect, even to the point of the AC itself being sliced. So we have a choice. We could clarify this by stating all of these points, calling it all out, or we could simply remove the discussion of agnosticism. And my preference here is to say, what's quoted here, the service is agnostic to the technology in the underlay network, and leave it at that. And I pause a beat while nobody comes to the microphone, which, hooray, good. Lue.
So I support your opinion, because the way you look at it is inside the network, you can use whatever, it's about the what's on the house, right? So you can use whatever technology you want. It's agnostic. You can do your slicing. However, to receive that endpoint that's coming from a different domain, I agree, that's a technology specific. When we were looking at it, we were looking at the F1 interface, the N3, the N6, and in none of those we were really agnostic. We were, but to your point, as soon as we identify where the slice or what is the slice, the rest of it becomes technology agnostic. So hopefully I said the same thing, but I support that view.
Lovely, thanks. And Kariti.
Goes back to the intent versus implementation. Intent, you want to stay away from how you do it. So you say, this is my connectivity matrix, this is my requirements. I don't care how you do it. So I think I'm echoing what Lue just said. And so the agnosticism I don't know if I put too many S's in there, is with respect to how you implement it.
Yes, yes. I think that was the point of the original text. It's just the original text wasn't clear enough about where that agnostic boundary was. So I will try to tidy that. Brilliant, thank you. Next slide then. Okay, so other issues, I'm going to say let's not raise other issues here and now, because otherwise we will overflow. Please send to the list, and I will also try to capture what we've already covered in this meeting as issues on the list. And then next slide. So my plan is to get another pass of this during November, and obviously raise the issues that have been described. There's enough going on that I think we have to push this out probably by an extra revision. But I think with 06, we will be close to a point where I'm calling on you all to do a pretty thorough review, preferably during this calendar year, so that we can start to tidy up all of the remaining issues in January and February, and maybe be ready for a last call before the next IETF meeting. That would be my hope, because this document is kind of important for progressing everything else, and if we can't get consensus on it soon, we'll be slowing down our other work. If I may, given there's 11 minutes, can I share my desktop and share a slide on the VPN Plus and slicing discussion? I will ask to share screen. All the slots are taken. So we need Pavan to...
Sharing. Actually, I'll do it.
There we go. Yes, I really want to share my screen. Really, really, really. And if it's working, yeah, it is working. You can... Oh, come on, share away. Hopefully you can see a PowerPoint slide.
Not yet.
La la la. All right, so it's giving me a choose what to share, and here is a grayed out button where you can only cancel.
Maybe cancel and retry.
Yeah.
You click on that screen above that grayed button.
Yeah. All right, here we go. I love it when it does that. Cascade, right. You've now got it as soon as MeetEcho actually distributes it.
Changing topics on us.
Well, yeah, this is still slicing, and since you said maybe we can squeeze this in at the end, and since I'm talking and I've got the slide, I thought I might.
So let's do it at the end.
Okay, all right, I'll come back later.
All right, thanks.
In which case, I think I'm finished. And
Adrian, thank you very much for running the last almost hour, and thank you all who contributed both here and to the work. It's really important, and we appreciate the timeline and pushing to get it out. And thanks again. Reza, you're up.
Yeah, can you hear me?
Yes.
Okay. Hi, everyone. On behalf of the co-authors of NBI draft, I'm going to present lots of discussion that I'm going to talk about. It's already discussed in the previous session, connectivity metrics and everything related to that. So, and The considered whatever is discussed here is just from the modeling perspective. We are not going to go to the deep dive of this. Assumption is the framework is going to cover that one. Next slide, please. We are going to talk about connectivity matrix modeling. Whatever is a kind of summary of where we are right now and whether or not this is agreed upon. And there are some other discussion that needs investigation, namely network slice connection group, introduction of tag, and how the realization relates to the underlay. So these are some of the topics that will be discussed today. Next, please. Regarding the connectivity matrix, so it's just a kind of summary of whatever we just seen so far. Why we need connectivity matrix? Why we need multiple connectivity matrix? Again, from the modeling perspective. If this is the case, how we can model it and how basically the type of the traffic will address or will be included in the model. So we summarize everything into two models. The first slide is option one. This is something that is included. If you go to next slide, please. So why we need multiplicity of the connectivity matrices. So these are two reasons that it's kind of summary of whatever that we deduct from the discussion mailing list and draft. It might be more reasons, or there might be some other reasons that some of them is not really included here. But the idea here is we need multiplicity of the connectivity matrices because one network slice endpoint, again, everything is from the technology agnostic perspective. One network slice endpoint can send traffic with a different type. Consider blue, red, and green as a three connectivity matrices that we have. So one endpoint is sending different type of the traffic, potential to different type of the NSE. And in the case of red and green, you will see same endpoint on the left-hand side sending to the same endpoint on the right-hand side, but potentially the SLO is different. And we consider every technology a specific term like class of service, type of services, everything from the modeling perspective is considered as SLO or SLA in this case. So potentially there are different SLO that's supported, and two reasons that we came up why we need multiplicities here. And why we need this, because in the modeling that you will see momentarily, this will be included. There are two options to model connectivity matrices. Next slide is showing you the first option. If you go to the next slide, please. So this is aligned with whatever we just discussed in the framework. For the sake of the argument, because they say, what is the connectivity matrix? The intention here is that we try to say each color is one connectivity matrix. So in a single IETF network slice, again, the assumption here is we have only single IETF network slice service. It contains 4 different metrics. Each color is one of them. Definitely, each one depends on the type of the traffic they send. They have multiple sender and receiver. In the case of everything except point-to-point, everything else, it seems that most likely are multicast traffic. But we had some argument before that it might not be the case. But consider everything first. First of all, connection is one directional. In the case of red and orange, you will see in the picture that each one has one direction. And in most cases, each direction has different SLO. So multiple SLO must be supported, shall be supported by the model, because upstream and downstream traffic most likely has different SLOs. And from that aspect, it should be trivial and simple to understand that the multiple SLO shall be supported by the model. And here, the intention here is, the first option here is based on whatever framework described as a connectivity matrix. Any type of the connectivity, for example, consider the orange one. The single point-to-point, one sender, one receiver is one connectivity matrix. Consider a matrix as one connection. This is the first option. This is what the framework discussed. And on the right-hand side, connectivity matrix entry, the intention is to try to put some example here to at least give a context here. I see there is Pirteke wants to ask a question, but I'm okay. We can stop here. Go ahead with your question.
Question. Thank you. So when you have the blue matrix blue connectivity matrix on the top, I think you tried to say it, but I didn't catch it. Is it NSE is multicasting to NSE1 is multicasting to NSE6 and 2, or is it 2 unicast? No, is it a total of 3 unicast connections?
No,
or
this is the point that we try to raise. For example, you can have multiple, and when I showed it, maybe the second option that be clear, but in this case, this is considered as a multicast. One endpoint is sending traffic to us. Basically, from the data path perspective, there is the data replication. This is one of the important things that, again, when we define connectivity matrix in framework, we consider when there is a replication in the data path, it's a kind of multi-point or point-to-point, multi-point, anything that has multi-meaning, there is a replication in data path. Everything else which is not, for example, point-to-point, at the end of the day, you can have an end-to-end multiple endpoint on the point-to-point, but they are sending unicast traffic. Each node can talk to each other, but necessarily traffic from one node goes to another node, and that could be from implementation point of view. You can have hub and spoke or full mesh, for example. But this is a clarification that the attempt was to put it here. Whether or not this is something that framework is going to address it very clearly and we bring it here, this is just the intention so far, whatever we understood from whatever discussed in the framework. I hope I answered your question.
You did, but I'm still a little confused because if you're trying to describe the SLOs for the multicast connection from NSE1 to NSE6 and NSE2 at the same time, but they're physically different distances, different fiber paths, and different all kinds of things. How do you describe, say, delay? I mean, do you give the minimum delay, or because even though you're multicasting and replicating the traffic, the characteristics of that traffic over different paths will be different. So how do you model the SLOs?
Yeah, good question. And if you go back to the right-hand side, the third bullet is basically addressing that. So each connection can have different SLO. So whether or not we consider the connectivity, in this case, from NSE1 to 6 as one connection to NSE2 another connection, you can potentially have multiple SLOs. But maybe this is addressed in the option 2. If we go with option 2, this is maybe we clarify that, but various or multiple SLOs should be supported. And I think you gave just an example of why we need that one. We want to have different characteristic for each of those connectivity that you see in this picture with the different potential SLO. They might be the same. I mean, this is very trivial case, but they might be different as well. If you allow me, let me just go to option 2, and after I take question. Maybe in the option 2, we answer some of the question that you have. In option 2, it's very similar. In the previous one, the ID that identifies a connectivity matrix was a new ID that we introduced. It could be integer, could be a string, could be what have you. In this case, the picture is very similar, but just consider the red connectivity and black. This is a bit different from previous one. In this case, the red connectivity matrix has multiple NSEs that's sending the traffic. So basically, you have a single red connectivity matrix, and in this case, the key is not only an ID, but it is the ID, which is red. In this case, blue, red is that ID. It could be integer or could be a string, and type of the traffic. With this one, basically you can address the connectivity block as well. Between two endpoints, you can potentially have multiple connections with different SLOs. And one example is not the example. One example is, for example, in the ORAN for the 5G, they ask about having multiple QoS inside an end-to-end network slice. This is again one example that why we need a feature or a characteristic like this. But in this case, as I mentioned, connectivity metrics could be anything. I put it blue, red, but it doesn't mean necessarily is a string. It could be an integer. It could be type of the class, whatever we can select here, it can be there, but just for the sake of the technology agnostic, we call it ID. Now I can go to Shofang's question.
Hi, Reza. The complexity we are discussing here is the exact reason why I'm against multiple connectivity matrices in a single slice. So the same feature and the same functionality can be achieved by multiple slices, and each of them will have only one connectivity matrix. That's my comment. Thank you.
Yeah, this is one point, and actually the model that we have in the draft right now is exactly as you mentioned. The assumption here is we have a single connectivity matrix because of the reason that you say. If a customer wants to create connectivity blue, why they have to put in this one into network slice 1? Create another network slice 2, IETF network slice 2, and put that one there. This is exactly valid reason, and this is at the group we have to think about it, whether or not multiple connectivity metrics shall be supported or not. But either or is fine with the modeling, but this is the model this way because of existing framework which addresses this way, that multiple connectivity matrices shall be supported.
Hey, Reza, you have exceeded the allotted time. Can you rush through the remaining slides and then take questions?
Let me just finish
if we can.
Okay, no problem. So let's go to the next question. Next slide, please. Sorry, the Italo. We can take your question at the end. So there are other aspects. For example, there is one discussion about the network slice connectivity group. And the whole idea here is, if there is an endpoint sending traffic to multiple other endpoints, maybe the aggregation of the characteristic, for example, each one sends 1 gig, but accumulatively, the total traffic should not exceed above a certain amount. In this case, we need to introduce network slice connection group. Again, this is under discussion. We will be providing more information in the mailing list. The next topic is tag. If you go to the next slide, please. Multiple SLO should be supported. Again, this is a discussion that we went through it. This is more information, why it is the case, what are the use cases. Support on multiple SLO is one aspect that is needed to be completely clarified with the connectivity metrics. Next slide is, I think, about the tag. Why we need tag? We used to have tag, but it was removed based on some comments. So we believe, the co-authors believe, that there is a need for having a tag, which is a kind of association, quote unquote, between network slice, IETF network slice, and higher layer consumer. Again, this is will be discussed in the mailing list, but just gives a heads up that this will be one. And I think I have one more slide at the end. So there is a discussion about how from the northbound, the underlay information in some cases will be given to the network slice controller. Maybe the operator, maybe the orchestrator sitting at the top knows how to realize the transfer slice in the network. Is it possible for that to influence network slice controller to specify the underlay and how to do it? This is one aspect. Again, it needs investigation, but I think it's a good thing to discuss it. Whether or not it's needed depends on use case. This might be relevant to our discussion. And from that, I'm done, and we need more
Let's take
discussion.
one. Yeah, let's take one quick question from Italo, and then we can move to the non-working group documents.
No problem. Italo, please.
Can you go back to slide 6? Yeah, I think in this case, well, it doesn't matter. In my opinion, if you allow this situation, when you get a packet from the access link, you have three steps. The first step is you have to know which access link the packet is coming from. The second steps you have to understand whether the packet belongs or not to NSA number 4. And then you have a third steps. You have to understand whether the packet that goes from NSA number 4 to NSA number 8 should go over the red or the black. So you have three types of criteria that you have to configure for traffic classification. While with option 1, you have only 2. You have to understand the link and then which NSC the packet belongs to. And this, I think, is the key difference between the two options and have to be clarified in the framework.
Yeah, you're right. So this one addresses the very last portion that you mentioned. But anyway, your summary is correct. Thank you for your attention. Back to you.
Okay. So next up, we have Tarek. This is the start of the non-working group draft portion. We're going to really try to stick to the allotted time, max 10 minutes, hopefully a little less, just because we've managed to fill up all the slop time with good discussion on the working group drafts. So, Tarek?
Okay, thank you. Hi, everyone. I'm going to give an update on revision 4 of the solution to realize network slices in IP and MPLS networks. I am talking on the behalf of the co-authors, and I thank all of them for their contribution. Next slide, please. So my update, well, the agenda consists of the updates. I'll go in details about each one on the slide, and then I'll close off with the next steps. Next slide, please. So summary of the updates before we go deeper. We went ahead and incorporated the new term network resource partition. This has been debated on the TEAS mailing list and agreed on. So we went ahead and incorporated it in our solution. We have expanded on the steps required to realize the solution for IETF network slices in a transport network using our solution of slice aggregates. And lastly, we have addressed review comments from several working group participants. I will talk more in detail about each one of those. Next slide, please. So it's network resource partition. It's useful to flash some of the terms that we used in our solution document. First, slice aggregate, a collection of packets that match a slice policy selection criteria and are given the same forwarding treatment. A slice aggregate comprises of one or more IETF network slice traffic streams or flows. The mapping of one or more of such streams or flows into an aggregate is maintained in the IETF network slice controller. The network resource partition, our understanding of it is a collection of resources that are used to support the slice aggregate. And lastly, the slice policy is a construct that enables the instantiation of the behaviors on the select topological elements. The enforcement of the slice policy on those elements will result in the network resource partition. What I want to highlight from these three definition of the terms is the network resource partition is instantiated on a set of nodes and links using policy. The network slice controller is the one that aggregates the IETF network slice streams into and forms a slice aggregate or a grouping of those streams. The slice aggregate traffic streams share a common set of SLOs and consequently are given the same forwarding treatment by the traverse nodes. And lastly, the slice aggregate traffic is tiered on the specific network resource partition associated with this slice aggregate. Next slide, please. As I mentioned, we have introduced a number of steps in no definite order. We're not dictating a specific order in order for realizing the IETF network slice service. I'll just go over them one by one, but not in details. I'll leave interested parties to go and read our draft for the specific details. So we talked about network topology filters, slice aggregation, mapping, path placement on the specific topology associated with the slice aggregate, the slice policy installation or instantiation of the network resource partition, path instantiation, service mapping, and relationship between different network slice aggregates. Next slide, please. I mentioned that we got some review comments, and we did address them in this revision. We thank all who have read our draft and gave comments. So Jimmy and Robin had provided some comments, and we've addressed some of those. They were mostly editorial nits. Last IETF 111, Zafar had some feedback to incorporate some of the SR building blocks draft that he had into our draft, and he did signal an intention to join. From our side, we took an action item, and we addressed this. We did try to incorporate some of the building blocks related to SR in our draft. And we've given Zafar a chance to review the updated revision. We're still pending any feedback from him. Maybe he didn't get a chance to review the latest revision, but we did give him a chance to do that. Lastly, we did clarify the relationship of our solution to diffserv. We are highlighting that diffserv is not mandated by our solution, but if it is enabled, it will allow us to do or to support multiple classes of service on the same network slice or same, network resource partition, i.e. hierarchical QoS, support for hierarchical QoS. Next slide, please.
You go so there, before you go there, if you go back one sec.
Sure.
So there's actually been a little mail, I think, about Zafar's draft, and it looks like there's room. There's still not closure or alignment between this draft and what Zafar's looking for. If you can have that discussion play out, that would be great. And feel free to have it on the list, and so the working group is understanding what's going on. But Zafar, at least on email, says that there's more to do. And if we have time at the end, maybe we'll give him a chance to talk. All right, thanks.
Sure thing, no problem. Thank you, Lou. In terms of next steps, the authors think that the document is ready to be adopted. We do welcome further review from the working group, and any feedback is also welcome. Thank you.
Jimmy?
Tariq?
Yep.
Yeah, first of all, thanks for the update. I saw some comments from our side, and I think one of the major issues left is about the terminology. I think following the consensus from the discussion, we will prefer to use the generic terms for the slice realization in the underlay, so that it is related to the terminology like the slice policy topology, slice modes, policy modes, etc. Another terminology I have raised the comments in the mailing list is about the slice aggregate. I think its the usage in the text has been changed to network resource partition from this version, and I think it is important to clarify what it means and also clarify where it should be used and how it should be used in the draft.
Thanks, Jimmy. So let me clarify the definition of slice aggregate. In the current revision, it's clear the slice aggregate and network resource partition play different roles, and they are distinct. And and it's clearly stated in the draft what each is playing, the role of each. Now, if you still have any ambiguity, please raise it, and we'll try to address it definitely. In terms of terminology, we did align with what the working group has proposed in terms of network resource partition. We feel that there was co-authors think that it has quite an important role to play, and we feel it's important to keep in the solution. But I'm welcome to hear more. Feedback is also welcome.
Do the next two quickly, please.
Me? Hello?
I can hear you, Robin. Go ahead.
Okay. Tarek, in fact, Zhenbin from Huawei. In fact, I proposed my comments about the terminology slice aggregate in the mailing list. So that is my original understanding about slice aggregate is the underlay network slice. But now it seems to change to that to identify this the network slice stream. But I wonder I have this is a little confusing. Even in your slides, you mentioned that is the slice aggregate topology. I don't understand how to define topology for a group of the streams of the network slice. And the second one, I think that's another draft mentioned that the slice aggregated augmented to cope with the problem of the APN. I'm not sure that's what's the scope of this the slice aggregate. Is the identifier of some of the flow, or is it just confined to some of the specific network slicing related things?
Your voice chopped up on my side, so
restate the question on the list if it's not already covered, and to take the response to the list. Zafar, if it's super quick, please go ahead. If not, please respond on the list. Zafar?
It's going to be super quick. Yeah, so I had a discussion with Tariq, but we have not reached an agreement, and we are seeking working group adoption for the building block draft as well.
Well, if we're going to combine the documents, it's better to combine the documents and then move to working group adoption of the unified document. So let's see what happens with the work to bring these two documents together. And again, feel free to have the discussion on the list if that helps. And Tarek, thank you for the presentation. Everyone, thank you for the comments. And we have to move to the next slot.
Thank you.
Hello? Can you hear me?
Go ahead.
Okay. Hello, everyone. This is Jedo, and I'm going to give an update about the scalability considerations for the VPN Plus on behalf of the co-authors. Okay, next page, please. Or can I control it? Okay, a quick recap of the VPN Plus and the VTN concept. The VPN Plus framework is described in the TEAS Enhanced VPN draft. One of the typical use cases is to deliver IETF network slices service. And the VTN is a concept which consists of a set of dedicated or shared network resources, and it is associated with a customized logical topology. The VTN can be used as a virtual underlay to deliver the enhanced VPNs and VPN Plus service. As shown in the figure on the right side, we can have one or multiple VPN overlay services mapped to one specific VTN as a virtual underlay. And with the widely deployment of the network slice services, the scalability of the VPN Plus and VTN becomes an important factor to consider in the solution design. So this document provides scalability considerations of the VPN Plus and VTN. It analyzes the scalability in the control plane and the data plane, It also proposes optimization mechanisms to improve the scalability. Okay, next page. Okay, so here are the proposed scalability optimizations for the control plane. Basically, it is suggested that we can use a shared control protocols instance or session among multiple VTNs so that we can reduce the overhead for the session maintenance and also for the information distribution in the network. The second point is we can try to use a shared topology specific computation among multiple VTNs. When there are multiple VTNs with associated with the same topology, they can use the shared SPF computation result for the for building their forwarding entries. The third point is we can rely on the hybrid control plane, which with the help of the centralized controller, and it can use together with the distributed control plane for the path computation, for the information distribution, so that we can balance the load between the controller and the distributed control plane. Okay, next page, please. For the data plane scalability optimization, the proposed mechanism in this document is try to decouple the resource identifier from the topology specific identifiers used in packet forwarding. So the general approach is we can use a separate identifiers to identify the topology and the destination or the path. And in addition, we can introduce a dedicated identifier to identify the resources associated with the VTN. Based on this mechanism, we can instantiate it in the different data planes. For the IPv6 data plane, we have proposed to use the IPv6 hop-by-hop extension header to carry the VTN resource identifier. And there's also a discussion in the MPRS working group and other working groups about how to carry this information in the MPRS data plane. Okay, next page. Here we summarize the updates in the latest version. First, we update the descriptions in the abstract and the introduction so that it aligns with the update in the enhanced VPN and also the update in the IETF network slice draft. We also refine the descriptions about the scalability requirements about the VPN plus services and the underlay VTNs. The description about the data plane scalability and the description about the data plane optimizations are also refined. We also add the security consideration section in this version. Next page, please. Here are some history about the VPN Plus and VTN drafts. We have proposed the enhanced VPN Plus framework in 2017 and has been adopted in 2019. Then we proposed a segment routing-based VPN Plus and VTN mechanisms in 2018, and the work has been adopted in spring early this year. The SR-based mechanism is suitable for the small or medium-scale network slice scenarios. And then after that, we propose scalability considerations for the VPN Plus in early 2020. And after that, we have 4 updates in the past 20 months. So that we also have the solution work based on these scalability considerations and optimizations ongoing in other working groups. So on the right side, it shows the relationship between this work and the network slice work in the TEAS working group. So we have this general framework, describe the concept and the overall framework for the slice service. Then we have the realization based on the VPNT and other technologies at the VPN Plus framework. Then for the realization, we can have either the SR-based mechanism for the slice realization based on the resource-aware segments. We can also have this high scalability network slice realization based on this scalability optimizations and the data plane resource identifiers introduced in different data planes. Okay, next page. For the next steps, we think this document provides a detailed scalability analysis and optimizations for the control plane and data plane of the VPN Plus and VTN. It's complementary to the scalability considerations in the VPN Plus framework. and provide guidance to the protocol extension work. Regarding the terminology in this draft, we think based on the recent update of the IETF network slice draft, we can refer to the generic term network resource partition in that draft, and we can clarify that the VTN in this document in the context of the network VPN Plus is equivalent to the network resource partition in the context of IETF network slicing. Based on the scalability mechanism, we will collaborate on the protocol extensions based in the different control protocols with other draft authors. For this draft, the authors think this version has been stable, so we would like to request for the working group adoption on it. Thank you. Comments?
We have time for a couple of quick questions. Tarek?
Yeah. Can you hear me? Yeah. Hello?
Yes.
Okay, thanks. My question, I would like to see more alignment with the terminology that the working group is adopting. I think you're raising that. So network resource partition should be used instead of VTN, and I would like to see VTN go away before we call this ready for adoption. And second point I have is I don't think adding VTN ID in the packet or carrying the ID itself inside the packet is too restrictive associated to the we can have multiple mechanisms or selectors to map traffic to one network resource partition. That you are mandating carrying an ID inside the packet. And yeah, these are my two questions. Feel free to, and I'm willing to take them offline if you want on the mailing list.
Okay, maybe a quick reply. May I? Yeah. Regarding the terminology, I think we have agreed to refer to the generic term. Whether it should be a replacement or a reference, it is determined by the relationship between the slice work and the VPN Plus work, which we may discuss further offline. For the ID-based mechanism, as I mentioned, we can have either the segment routing resource-aware seed-based solution, which is suitable for the small or medium-sized network slices. The ID-based mechanism can improve the scalability, and I think this is also what you have described in your draft. So both mechanisms can be used in the data plane, right?
Okay, so we're out at the end of the slot. I apologize to the person in queue. I thought we would have time for them. If you can take the list, that would be great. We'll take the discussion on working group adoption to the list. I think if anyone who has objections, please don't wait for the adoption call. Please start talking about it right now. And the point on alignment is quite important. The VPN Plus can have scope outside of slicing, so think about that as you're doing your update. With that, we're going to move to the next. It is I think is it Tarek again, and we're going to cut you down to 9 minutes because each slot's running a little over. Thank you.
I think I may give you back some minutes here, but I don't see the slides yet. Okay. So this is the update on revision 2 of the slice policy Yang data model. Again, on the behalf of the co-authors. Next slide, please. So the update is straightforward this time. We did incorporate the network resource partition. I did talk about that in my earlier presentation. We replaced, previously we had an SAID to identify the network resource partition ID partition. We have introduced the NRP ID instead. And we've updated certain leaf descriptions accordingly to align. We have made a leaf ref change to align with the topology filter data model. It's basically an XPath change to make it compile, absorb the top level container change. So these are the two changes that we had in this revision. Next slide, please. So in terms of, we always welcome further review and feedback to the data model. This is an important data model about, about the slice policy that instantiates the network resource partition in the network. We think that the model right now is in a good shape to be adopted by the group. So we request working group adoption. Thank you. Dhruv is in the queue, and I'm happy to answer your question.
Yeah, thanks, Tariq. Tariq, I posted my comments on the chat as well regarding the terminology, and right now we say basically the slice policy results in the creation of the network resource partition to support slice aggregate. So I think this, like the term itself, slice policy, is not making too much sense now, since we have we don't map a single slice here. So I think we need to relook at the terminology once again. And even when we look at the Yang model, this part becomes quite confusing. So just a comment that, not just with this document, but the document that you presented earlier as well, that terminology is something worth looking at. And second comment, like while looking at the Yang model, in the section about PHP, where you are describing the rate and shaping, I think either we need to add a little bit more description, or maybe use references to some other document which describes those things in a much better way. Because right now when you read the Yang model, it's not very clear how is this getting applied, this whole bandwidth, how is it getting applied to a particular NRP. That's not very clear. So just think about those things, would be my comment. Thank you.
Sure, Dhruv. Definitely, if it is thin on description, we're willing to elaborate. And on the terminology, yes, we're open to, at least for the slice policy, we had a discussion among co-authors, and we're open if the working group thinks that calling it a network partition policy helps. We're willing to, to take that input as input, accept that. Robin?
My comments is that the data model depends on the solutions of the data plane and the control plane. But I don't think that the solutions of the data plane and the control plane is stable. So I means that this dependency should be solved before this Yang model be determined.
I'm not sure why you want to couple, the data model with. We are aligned with the slice definitions draft framework draft, and we if you have any points that you want to raise, feel free. If we are diverging.
My comments because for example, for the IPv6 encapsulation or the MPLS encapsulation, to how to encapsulate the ID, and also this how many bits for this ID.
So Robin, if you've read if you give it a read, then you will see that we have covering multiple options for having these selectors for IPv6 and MPLS as well. So multiple options are there.
But that is just my concern. Maybe there's the multiple options.
We have references to where each option is coming from. It's not, So we can take it offline, and I can point out each reference.
Okay.
Hi, Tariq.
Hello?
Can you hear me? Yeah.
Yeah.
Yeah. I read the draft, and the draft said the slice policy model is also a controller model, right?
That's correct. Yeah, it can be device and controller, correct?
Yes, but the model current model has only one bandwidth resource reservation for each slice policy. So I'm thinking when instantiating a network resource partition instance, do you think all links in a network resource partition instance are all the same?
So Bo, actually, the model allows configuring different bandwidth profiles for different parts of the topological elements in the network, and this is the reason we introduced topological filters or topology filters. So you can, in the model, you can say, my blue part of the topology, I want this much bandwidth for this network resource partition, and in my red admin groups, and this is just an example, I want a different bandwidth. So it allows you to do that.
Oh, that's not quite clear in the model, because right now it also regarding the like control, you mentioned in the model that there could be have a controller plane mode and also some data plane mode, but it seems that network resource partition only have control plane and resource and ID, but I don't see that there is some data plane resource associated with this network resource partition. So I think that is missing there.
No. It is data plane resource reserve. I mean, data plane resources are part of the data model, and I'm happy to point you to that.
Yeah. Okay. Hope there will be more example to show how in 3 modes how we can doing that.
Okay. Yeah, maybe your point taken. I think we need examples about how do we do each one of those points you're raising. Thanks.
Okay, well, thank you very much. It seems like there's some good opportunity for follow-up on the list, and we'll ask the folks asking questions as well as the authors to try to take that, continue the discussion. I believe, Reza, you're up.
Yes. On behalf of the co-authors, I'm going to present one of the application of the IETF network slice in the context of 5G, and in a specific how the mapping should happen and what are the options that we have. Next slide, please. If we look at the general the management of the 5G end-to-end network slices, in this example, and as discussed in the framework document, I think it's important to understand 5G is one of the applications or the use cases of IETF network slice. As a technology, it was clearly defined in the framework document that IETF network slice is a technology that provides various use cases. One of the use cases is 5G, and in the context of the 5G, the way that end-to-end network slice from the left, if you look at the bottom picture from left, which is your UE, it could be your cell phone, your IoT device, could be CCTV and what have you, to the right-hand side, which is a UPF, and which basically addresses the connectivity which is needed for that UE to the network. So from this perspective, it is really end-to-end context. It has various domains, RAN domains, transport domains, and the 5G core domains. To create this end-to-end network slice based on the 3GPP, this is a kind of summary of whatever is proposed. There is an entity sitting at the top, and you see the acronym on the right-hand side. Basically, there is an orchestrator sitting at the very top, which is orchestrating creation of end-to-end and delegating it to the access network, AN, to the transport, which is IETF network slice controller, and to the core, which is the CN. Whatever you see in NSSMF is basically the controller. So any acronym with NSM means AN controller, domain controller, or CN. I'm simplifying it, but the idea here is orchestrator at the top send the request to create access a slice, core slice, or AN slice. There is a typo here. It should say CN slice identifier. And it sends a request to IETF network slice. This is a discussion that we had for last hour or so to create quote-unquote connectivity between them. So the whole idea here is that there is one identifier from the 3GPP and from the end-to-end context. It's called network slice selection ID, SNSSAI. This is just a 32-bit number. It has a semantic, but for our discussion, consider that there is an ID which is used during the signaling from 3GPP, from the UE to the network, which identifies the whole end-to-end network slice. So from our side, how we can take from the transport specific, how we can take this ID, SNSSAI, to map it to transport, and there should be same question for AN and CN, but our discussion today is explicitly from the transport perspective. So if you go to the next slide, we try to basically formulate this question into more detail. So you will see here that for an example, there is an end-to-end network slice with the ID at the very top. 0111 is a 32-bit number, as I said. It creates some AN slice, access network slice, and there is an ID allocated, with what the controller to that. Same thing, there is some network slice, the IETF network slice will be created, the ID is 6, and same thing for the access for the CN, for the core network. So the whole idea here is, at the end of the day, AN is connected to the transport network through a network of PEs, and same thing, CN is connected to PEs. The idea here is when the traffic from the AN, look at the data plane, the bottom line, bottom portion of the picture. When the traffic arrives from the AN, it should have some identifier. This identifier, we call it IDA because there is no specific agreement what that should be and what the acronym should be, but consider that one as a IETF network slice internetworking identification. That packet comes to the network, to the PE, and PE knows how to map that one to IETF network slice with a specified with the ID. Again, we put IDB because we can discuss what that should be. It seems that there is a question. I can take the question right now if it's related to this slide. Kurteki, please.
So you're saying the IDA is in the data plane in the packet as opposed to a conceptual identifier? I mean, it's possible that the PE could say, I'm going to use a 5-tuple, IP 5-tuple or incoming interface and VLAN ID to do the mapping instead of having an actual ID in the packet. But from what I hear, you're saying it's an ID in the packet.
No, I didn't imply what are the solutions. For example, you mentioned VLAN. This is one potential solution. This traffic, which is coming from AN to PE, potentially will have some identifier, whether or not is in the packet, IP packet itself, because at the end of the day, that traffic which is coming in 3GPP term, they call it GTP tunnel, but it's basically nothing but IP on top of UDP. So potentially that IP can come with a VLAN, and that VLAN is identified. We are not implying that there is an ID internal to a packet, and the whole draft try to basically formulate the options that we have. I'm just doing the time check here. I go with try to finish the slide, and if there is a time, we can take question at the end. Let me just go to that. But it's very important question that you asked. We are not implying that there is a specific ID attached to the IP. What are the potential solutions that we have is basically addressed in the draft. If you go to the next slide, please. So there are some updates that happens to the version 4. There are lots of detail added. Some of the terminology which is not really needed has been removed or revised, and I'm encouraging people to take a look at this one. There are fresh look at the problem. We try to align it with the IETF network slice draft and basically simplify it as well. If you go to the next slide, there are some clarification about some of these as much as I have time. So you will see here that the whole idea of the creation of end-to-end network slice, assume that these three colors that you see here, there are three end-to-end network slices. The whole idea here is when the traffic goes into one of these, let's pick the green one. When the traffic from the access side comes to the IETF network slice 7, what are the characteristics of that IP, the traffic which is coming, and what can specify I need to connect to the network slice green versus blue, for example. This is the whole idea of the problem statement that this drive tried to address. This is just an example of that. If you go to the next slide, the clarification between whatever on the left-hand side, the picture that you will see, this is the view of the 3GPP, that there is an orchestrator sitting at the very top. There are three controllers for three domains, for the access, for transport, for the core. The terminology that we use, the attempt here is to map it to whatever we understand. Basically, from the perspective of the transport side, the IETF network has a controller. Quote unquote, that TN NSSMF is equivalent of that, and anything sitting at the very top is just an orchestrator. In our terminology, that entity is the consumer versus customer. This is one of the topic that Adrian also mentioned. But at the very end, there is an entity sitting the northbound of the network slice controller, and there is something southbound. So from our side, basically, we are addressing only whatever is happening at the IETF network slice controller, and this mapping is clarifying or mapping what we have. So we have only maybe less than a minute to finish up the thought here. If we can quickly go through the slide. Next one, please. So there are two IDs, IETF network slice identifier. So what is that ID? Based on whatever Tarek and other mentioned, we have to come up with that ID, and also inter-network ID. These are the two IDs that we have. And if you go through the document, if you go to the draft, now it says how we can map these two IDs together. One example is whatever that mentioned. For example, VLAN is one, but it's not the only option. There are various options discussed in the draft. And the whole idea here is we are not imposing any specific. The mapping is just trying to list all the potential solution that exists today. And in this context, we just trying to put everything together. And for the, if you go to the next slide, we are seeking more comments, and also we think that we are reached a stable part, which we are aligned with the IETF network slice draft, the framework, and we are seeking for the next step and potential adoption. Thank you very much. And I don't know if you have time to go through one question with Loay, but if it is, please go ahead.
No, Loay, you might just want to speculatively jump in before into the queue on the next one.
Yeah, I'm going to make the comment.
Cut you off twice. I apologize.
Yeah, let me make comments real fast, if that's what you want me to do. I mean, and we can take it off the list, or I can do it on the list.
Sure, make your comment and then take the response off list.
So I'll tell you, you need to, from the picture I see N6 interface, I don't see how it applies to the F1U. I mean, see the N3 interface. I don't see how it applies to N6 and F1U. So that's one thing to consider. Another thing to consider, you might have multiple DUs talking to a CU, multiple CUs talking to UPF. If you understand this, take your model. When somebody mentions VLAN, make sure you understand the use case before you propose a solution. So we can talk offline, but let's try to apply it to the use case to see if this is efficient or not.
Definitely. I simplify it here, but we can talk if you want. We can have more detail on that. But yeah, the point is taken. Thank you.
And please continue the discussion on the list. I believe there was interest in a past meeting in this document. We had, gotten some indication from the working group. There's interest in this work. So please discuss it on the list. And, I think we're headed towards adoption, but we're not quite there yet. Moving on.
Thank you.
Robin?
Okay, yeah. This is Zhenbin from Huawei. My presentation is the framework for end-to-end IETF network slicing. Next slide. Okay, here this is the background. In fact, this has been talked many times in the previous section. So here this is quickly. So the first that's the there's the draft from the design team define the concept and the general framework of IETF network slice. And also we have this realization based on the VPN plus and the VPN plus and the VTN. So this is we also have the SR-based VPN plus mechanism. And now that's because in the past work, major is for the single domain, but because of the deployment of this the network slice, so that IETF network slice may span multiple network domain. In each domain, traffic of network slice service is mapped to a local VTN. So this document is to describe the framework for realizing end-to-end IETF network slice. Next slide. Okay, so here this is just this the brief, this introduction about this system. That is about this framework for the realization. We have this SR-based network slice realization. Now that's we also have the scalable network slice realization to decouple this network slice and the topology. Now that is for the end-to-end IETF network slice realization to implement IETF network slice spanning multiple network domain. So this is the draft. Okay, next. Okay, so here this is just this end-to-end IETF network slice. So here see that's this the top layer. This is the 5G end-to-end network slice, which is identified by the SNSSAI. So that's in the transport network segment, the 5G network slice can be mapped to an IETF network slice. For the IETF network slice, it can be realized with multiple domain VPN plus service. And also in the underlay network, the multiple domain VPN plus service is supported by a multiple domain VTN, which is comprised by multiple intra-domain VTNs in the different domains. So here we have this the different layers of this the ID, so that we have this the 5G network slice ID SNSSI, and also we have this the IETF network slice service spanning multiple domain. That is a global VTN, and for each domain we have this is a local VTN. Okay, next slide. Okay, so here this is just summarize this identifier. So that is for each domain, a local VTN is carried in the packet to identify the set of network resource reserved for the VTN in the corresponding domain. We also have this global VTN ID. So this the global VTN ID is a global value for spanning multiple domain. It can be mapped to a local VTN in the corresponding domain. And also for the 5G, we have this end-to-end network slice ID, SNSSAI. In the previous presentation, the interworking between the 5G network slice and the IETF network slice, it can use existing encapsulation such as the VLAN, etc. Here, this introduce another method. That means this SNSSI can be directly carried from this the RAN to the IETF network slice, then to the mobile core network. Okay, so for this the IDs, so that's the local VTN ID is mandatory, because this is must be forwarded in the in each domain. But for the global VTN ID and the 5G SNSSI, for the spanning the different domain, these IDs are optional. Okay, next slide. Okay, here this is a requirement of the end-to-end IETF network slicing. So this is the data plane. So that's the ID will be carried, can be carried in the data plane. So that's the waiting ID is mandatory, but for the other two IDs is optional. Accordingly, so there's the corresponding the manage plane and the control plane the extension. So that's is the based on the network controller. It can allocate these IDs and also set up the mapping entries between the global waiting ID and the local waiting ID, or is to set up the mapping entries between the global waiting ID and the 5G end-to-end network slice ID. That's the SNSS-AI. Okay, next slide. Okay, so here these updates. So this version is was submitted in April this year. So the updates of this, there are one version. So we refined the description of the VPN Plus and VTN in network slice realization, and the new co-authors are added. Then there's some of the editorial change. Okay, next slide. Okay, next. So that's the. So here we still use that's the realization terminology VPN Plus and the VTN. So that's the according. We will align the terminology according to the rough consensus in the working group, such as the network resource partition. We will refer to this the new terminology. Then we also go on to that's the solicit comments and refine the draft. And also from our point, so that is the concept is direct and clear. So answer is almost stable. So that's possible. We would like to request for working group adoption. Okay, that's all.
I think we have time for a question. Sorry, Tarek, go ahead.
Sorry, the title drew my attention. Do we have a new framework for end-to-end network slicing? Oh, sorry, for network slicing? Is this a new framework?
New framework. I mean, so that's the realization for the realization framework for the IETF network slice for the scenario, the spanning multiple domain. I mean, so that's the.
I would have thought it would be covered by the existing network slice framework or definitions draft. But I mean, I'll let the authors of or the editor to comment. Thanks.
Okay, Tarek, that's just also my question on that draft. I mean, so that's the scope. I'm not sure what's the boundary of that draft. It seems it can cover every the possible new things proposed.
So I think it's a good action for the authors of this document to look to see what text they think is missing from the existing working group framework document and propose text additions there. Clearly, some of the text doesn't belong there, like the applicability of VPN Plus. I mean, that could go in the VPN Plus document. But you know, it's a rather short and thin document. It would be good to just understand its applicability. You know, how much of it could be taken and put into the framework rather than have a whole new standalone document. So that's a request from the chair, and we could probably take the response offline on the list if you don't mind. Thank you. And with that, is it Pavan? Are you up?
Yeah, that's me. So this is not a slicing presentation. So I think I've gone past all the slicing presentations for the day. So in this presentation, we are introducing a data model draft for discussing topology filters. The 00 version for this was published before IETF111, but this is the first time that we are presenting it in a working group session. I'm presenting this on behalf of my co-authors Tarek, Rakesh, and Shifeng. The topology filter construct was originally defined as part of the slice policy model, but given its generic applicability, we decided to publish it as a separate standalone module. As the name suggests, topology filter is a filtering construct that can be applied on a native topology or on a predefined customized topology. The result of this application is a filtered set of topological elements. You could use the term filter topology for this as used in other documents. As part of this document, we are also introducing a construct called a topology filter set, which is basically a union of topology filters that can be applied in tandem on a topology. And also, as you would expect, the data model introduced in this document is applicable both on a network element and on a controller. This is an illustration of the high-level model structure. The data tree includes a list for topology filters and a list for topology filter sets. The top-level container that is being augmented here is the networks container from the IETF network module. The initial thought was to augment the routing container, but it has been rightly pointed out. I believe it was Bo who pointed that out, that routing container is a network element only construct, and that we need to augment a top level container that can exist, say, both on a network element as well as on a controller. So that's what we have right now. So the next three slides, they talk about topology filters container.
Thank you.
Okay, let me run through. I mean, I don't have many slides. I'll just quickly run through and I'll take the question. This is so the topology. Each topology filter entry in the list specifies a set of include any, include all, and exclude filtering rules that can be applied on either the native topology or a customized topology. The topology, each topology filter entry, it may carry a reference to the topology on which the filtering rules need to be applied. If there is no reference present, then the filtering rules are to be applied on what constitutes your so-called native topology. And as indicated here, the reference topology could be a predefined TE topology, RFC 8795 topology, and or a specific IGP domain. The topology filter entry allows you to also specify a varied set of attributes as part of the include any, include all, and exclude constructs that can be used as rules to filter the topology. We have had some asks to add a few more attributes to the filtering rules, and there was also an ask to include exclude all. We will be looking to do that in the next revision. If the entry does not carry any filtering rules and only references a specific topology, then the reference topology becomes your filter topology as is. The topology filter set construct, this comes into play when there is a need to create a union of multiple topology filters. And as you can see here, each topology filter set entry carries a list of topology filter references. So this is still early days for the draft. The authors do believe, however, that the document is sufficiently cooked to progress to the next stage, but the ask for now to the working group is just to review the document and provide feedback. That's it. I'll take questions. Sue?
Am I hearable? Okay. Yeah. Clear questions just to set context. To compare and contrast with the existing work. Mm-hmm. So you have routing filters, lots of them in good routing models. You have lots of flow filters in BGP. And then you have this topology filter. Could you compare, contrast, and give me examples where each one fits? Thank you.
So the topology filter, the mandate is very simple. I mean, there are a couple of use cases. Think of any computation profile. Today, we do pass in a topology and say compute a path within the topology. But say you have a customized topology, and on top of that, you want to do the computation only on a filtered set of elements, you can apply a topology filter. the other use case for which this was originally put together was like it was presented earlier with slice policy. If you have a network resource partition that has an associated filter topology, you need some way of saying these are the filtered set of topological elements on which your slice traffic needs to go through. So that is.
With all deep respect for your expertise, tell me why that isn't just repeating to me you've just done routing policy. I must be missing something, because everything you've just said is equivalent to routing policy,
If you can
which creates.
If you can point me to a data model that mirrors what I've just explained, where you can reference the topology and say filter it using so and so filtering rules, I'd be happy to just reference
If
it.
you look at the
I
body
couldn't
of
find.
if you look at the body of BGP models, you will find they do that. I think we're talking. I thought I asked something that was a fairly simple question, but unless you take up the BGP policy work and all of its ramifications, which is implemented here in other places, it constrains routes. If you're constraining topologies of peers, that's a different thing, but I can't tell whether you're constraining topologies of peers, topologies of end nodes. I really can't tell what this is doing, and I thought I asked a simple question for understanding, and I'm pointing you to several bodies of work. So I'm confused, Vishnu, with the deepest of respect for your expertise.
I will take a look at those references that you provided, but the last time I checked, I couldn't find any data construct that I could use to apply on an existing topology and get us get a filtered set of topological elements.
I'm asking a very high-level question, and my question then is, what's your background on policy routing? I'm not trying to.
So
I think
you guys are actually talking past each other.
That's what I'm thinking, Lou. So I guess I'll go away.
So I think
really,
what you're focused on is about routes, while what Pavan is focused on is topologies, and maybe we should have some references on the list to show.
No, Lou, that is incorrect. I am asking the high level question that says, have you looked at the combination of work? And it's
and I think policy, you said yes. I mean, I accept that you may not accept the answer, but he answered that question by saying he looked at it and didn't think it was appropriate.
And
so I'm happy to look at them
then
again.
I guess I'll object that this, I think, is missing a body of work. And I guess the only thing that, rather than getting an answer, I can do is say, thank you very much for entertaining my questions, and I object, Lou, to the work. Thank you.
Right, and this is, and we can continue the discussion on the list.
I'll raise it with my AD. Thank you very much.
Sure. All right. With that, unfortunately, Dhruv and Loa, we do not have time for your questions and the last presentation, so I think we should move on and ask you to take the question to the list. Apologize for the time management there.
Okay.
Last up.
Okay. Zhenbing from Huawei. This is a new topic, the intent-based routing. Okay, next slide. Okay, so here this is the introduction about the background. In fact, the seamless MPRS SR has been proposed to describe the requirement for end-to-end intent-based paths spanning multiple domain networks. And corresponding the protocol extension of the BGP has been proposed. But we know that because of seamless MPSR, this interdomain SR path need to set up according to the pair, color, and endpoint. That means more SR paths need to be introduced in multiple domains. So that this will cause more challenge on scalability. So in order to reduce the scalability challenge introduced by the interdomain routing, so that's this document propose the intent-based routing mechanism. That means that the the intent information can be carried in the data plane. So the network nodes can steer the packet into the SR policy or the underlying network slice to satisfy the service requirement. So that's the service requirement means specific intent. Okay, next slide. Okay, so here this is the some introduction of the concept. So this first is the color. So that's the color is used is defined in the segment routing policy. So that the color is used is a 22-bit numeric value that associate the SR policy with an intent. So means that's the, for example, the color means this is a low latency. That's for the SR policy. Okay, under the intent, this is a new concept introduced by the intent-based routing mechanism. So this the intent information is carried in the data plane. This is different from the color. That means associate the SR policy in the control plane. So that is because they both of color and the intent can represent some this the intent information. So there can be mapping between the intent and the color. So here this is a figure to show that the intent X can be mapped to the color Y if there has the same meaning for specific intent. Besides this mapping, because the color is always used for the SR policy for the steering traffic, the intent is not confined to the color. It can be used for other purposes such as network measurement and security, etc. Okay, next slide. Okay, so here we can see that's the for the for the inter-domain network. So that's the for the network node at the edge of the each network domain, the SR policy group can be set up. The SR policy group includes the mapping between the colors and the SR policy for specific endpoint. So when the packet arrived at the edge of the network domain, it can, according to the destination address in the packet, to search the SR policy group that for the endpoints. Then, according to the intent information in the packet, map to the color, and according to the mapping between the color and the policy, to search get to the SR policy, so that can steer in the packet into the corresponding SR policy to satisfy the intent. Okay, next slide. Okay, so here this is the color used for the underlay network slice. So that's the same, the color mapping, the mapping between color and the local underlay network slice can be set up in the data plane. When the packet arrived, based on the intent information in the packet, it can be mapped to the corresponding color, then corresponding to the corresponding underlay network slice. So then we can steer the traffic into the underlay network slice to satisfy the intent. Okay, next slide. Okay, so there's some the advantage. So this is the scalability. So this the mapping between the intent and the SR policy can be done locally without the need of advertise the label binding for the pair, color, and point to stitch the SR path in different local domains. The second that is the flexibility, because the intent can be satisfied by the different solutions. For example, the intent can be satisfied by the SR policy or the underlay network slice. So for spanning multiple domains, so the one domain can use the SR policy for the intent. Another domain can use the underlay network slice for the intent, so that we can flexibly to combine these solutions for the same intent. So this is achieve the advantage of flexibility. Last.
Robin?
I've lost audio. I'm not sure if everyone else
I
has.
think we lost Robin. I think we are at the top of the hour.
Yeah, I mean, this is interesting new work. I'm not 100% sure it belongs in TEAS, and unfortunately, I was going to ask that as a presenter. I'll have to take the comment to the list. We are pretty much out of time. I see Loa, you just joined the queue. Go ahead.
I just wanted to say that I think that this, for the time being, it actually belongs here in TEAS. It has a strong traffic engineering possibility, I think.
I think we're okay with it being here for now, but we'll continue to track and coordinate with the AD. We are, so it's early work, so I'd like to hear more about it and see more discussed on the list.
Okay, sure, thanks.
Yeah, no, thank you for the comment. Given where we are on time, we should wrap up. Pavan, is there anything you want to add before we close? Or you can close?
No, yeah, we had a great meeting. Thanks to Adrian for all the time that he put in. Yeah, we did ask for extra time, and I think we managed to fill it in. Yeah, thanks everyone. See you next time.
Thanks everyone. Bye.